Hi everyone! Today we are talking about DHCPv6. You are probably now familiar with IPv6, which we introduced in the previous video. But you may not be so familiar with DHCPv6 in the IPv6 protocol stack. In this video, we'll introduce it. First, let's explain what DHCPv6 is. DHCPv6 is a dynamic host configuration protocol on an IPv6 network. It's designed for IPv6 addressing and is used to allocate IPv6 prefixes, IPv6 addresses, and other network configuration parameters to hosts. How did DHCPv6 come about? DHCPv6 is based on DHCP. As we all know, networks are classified as IPv4 or IPv6 networks. IPv6 is an upgraded version of IPv4. DHCPv6 is an adapted version of DHCP for IPv6 networks. For communication, a computer needs to know the peer IP address, router address, subnet mask, DNS server address, and more. Early computer networks are small in scale and relatively stable. On such networks, BOOTP is mainly used to allocate a permanent network connection to each host. As the network scale increases, the network configuration becomes increasingly complex. Address allocation becomes a problem in situations such as when computers frequently move or there are more computers than allocable IP addresses. The original BOOTP protocol for static host configurations cannot meet the actual requirements. The IETF designs DHCP to allow users to quickly connect to and disconnect from the network, improve IP address utilization, support diskless workstations, and more. DHCP enables a computer to obtain all required configuration information by exchanging packets. For example, it can obtain DNS parameters in addition to IP addresses. Also, DHCP enables a computer to quickly and dynamically obtain an IP address. Zero-touch provisioning, which we are familiar with, uses these DHCP functions. In addition to basic DHCP functions, DHCPv6 supports prefix delegation prefixes. In a hierarchical network topology, manually configuring IPv6 addresses offers poor scalability and is not conducive to unified planning and management of IPv6 addresses. The DHCPv6 PD mechanism allows a downstream device to request an address prefix from an upstream device and allows the upstream device to allocate an appropriate address prefix to the downstream device. The downstream device then automatically divides the obtained address prefix into subnet segments with 64-byte prefixes and sends RA messages carrying the subnet segments on the link that IPv6 hosts directly connect to. This enables IPv6 hosts to automatically configure IPv6 addresses, implementing hierarchical address deployment. How does DHCPv6 automatically allocate and manage network addresses? There are two modes. One is two-message exchange shown in the figure. First, the DHCPv6 client requests the DHCPv6 server to quickly allocate an address and the network configuration parameters to it. Second, the server quickly allocates an IPv6 address and other network configuration parameters to the client. This mode applies to the network with only one DHCPv6 server. When there are multiple DHCPv6 servers on the network, all the DHCPv6 servers can allocate IPv6 addresses and other configuration parameters to a client. However, the client can use only one of the addresses, which wastes address resources. In this case, four-message exchange is used to allocate addresses, as shown in the figure. First, the DHCPv6 client requests the DHCPv6 server to allocate an IPv6 address and network configuration parameters. Second, the server notifies the client of the IPv6 address and network configuration parameters that can be allocated. Third, if the client receives response messages from multiple servers, it selects the server with the highest priority and sends multicast messages to all the servers. Fourth, the server responds with a message that contains the allocated IPv6 address and network configuration parameters. So far, we have learned the importance of DHCPv6. But how does it ensure security and protect itself from being attacked? For this, the IETF has designed DHCPv6 snooping, a DHCPv6 security feature. It establishes and maintains a DHCPv6 snooping binding table that records information about a DHCPv6 client by intercepting DHCPv6 messages between the DHCPv6 server and client. This table contains user information such as the MAC address, IPv6 address, list, VLAN ID, and interface information. Based on this table, the device analyzes and processes messages as well as filters out attack messages, providing security servers for DHCPv6. Let's quickly summarize what we have covered so far. First, DHCPv6 enables network administrators to better control IPv6 address allocation, facilitating network management. Second, DHCPv6 can allocate network configuration parameters such as the IPv6 address of the DNS server and support features such as ATP. Third, DHCPv6 can allocate IPv6 prefixes to network devices, facilitating network-wide automatic configuration and hierarchical management. In scenarios such as SRv6 compression, there are high requirements on IPv6 prefix planning. In this case, DHCPv6 can be used for proper planning. In short, DHCPv6 simplifies Internet access for users on IPv6 networks, and DHCPv6 snooping ensures access security. As for DHCP, related functions are further enhanced after the IPv4 network is upgraded to the IPv6 network. That's all for this video. Thank you for watching.